how is this going to work? How can you use this workshop? Well, if you know R and you're confident, proficient in R, at least enough to, copy code and paste and stuff, then you can just follow along and do the examples as we do them. If maybe you're feeling tired and you don't want to, it's the last day of this conference, you can just watch. That's no problem. I think that you can still get something out of this from just watching, or you can do both and switch back and forth as your attention allows. Maybe you get tired and you just kind of tap out. Like, that's fine. I get it. If you don't know R very well, right. So you can edit out all the weird things that I say that aren't appropriate for being on the internet. Yeah. But if you do not know R, then I would suggest, just watch, come back to this when you have more time, when you're in the right headspace to like, okay, let's figure this out. All of the code, the slides, everything will be available and you can use this. And obviously you can reach out to me because I really do like talking about this stuff and working on this kind of stuff. So there you go. If you want to follow along the presentation, in fact, I recommend that you do this. There's a QR code here. I'll give you a second to get into that, and then I'm going to show you what that brings up. You'll see it as well, but before you start tapping on things and stuff, give you just a second there. While we're waiting. So the beginning part of this, I'm going to talk like kind of data visualization theory, I guess, if that's a real thing. And then as we move along, we'll start getting into concrete examples. And then at the end, depending on how interested we are still and how much time we have, then we can do like some kind of problem sets-ish kind of thing. Or I don't know, look at other data, whatever everyone wants to do. So if you use the QR code, well, again, I can't see everything I need to see here. It should open up this page right here. There's the slides from a different version of this I did. It's actually almost exactly the same. So whichever one you click, well, click on the U of A one, but I'm just going to, every time I do this workshop, I'm just going to start throwing them here. The exercises are down here. If you do not know R at all and it scares you and you're not sure about your abilities to make things work, I would click on the web R link, which will take you to, it's just a website right here, but you don't even have to have R installed. You can just go through and you can actually just click the button and it'll run the code for you in the browser. Okay. Yeah, this is a new toy for me, so I'm testing it out. You guys are my guinea pigs. But if you do know R and you're confident in your abilities to use the script, if you click the R script one, it'll open up another link that has like basically everything that's in the browser where you can actually download the script, copy and paste it into R, just open it in R, and then you can actually run things into the console as you go. So whichever you prefer. I mean, you could put it in our markdown and put the whole thing into a chunk and then organize it later, or you could do it either way. I would probably just do it in our script. That might make the most sense. But if you know how to use that, then I would say definitely do that. Or you can even start with one, and if you get tired of sending things to the console, switch to the web R one. In any case, we're not going to do anything actively in R for a little bit, so you have the option. You have time to think about it a little bit. Also, since this is clearly low stakes and very, I hope, kind of, we don't have to be like worried about asking questions. You can just stop me at any point and ask me a question. Not a problem at all. Are we good? Cool. So you've made your decisions. What are the goals of this workshop? So, our goals of data visualization, I'll start with that. As researchers, we want to make elegant, truthful plots. I think the truthful part here is more important, but I think, you get a point like, well, if I'm going to do it, I want it to look good, right? We also want to help the reader understand your data or understand whatever point it is that you're trying to convey. Sometimes we forget that. When I first started doing this, and I'm going to show you some of the first plots I ever made in this program, and I won't say whose class it was, but you'll probably be able to tell. Sometimes I just thought like, this is something I have to do. Like, where's the button to make the plot? And I didn't put any thought into it. And like now before I even do anything, and I'll sit down and I'll think about like, okay, what's the story here? What's the important aspect of it? There's a lot more thought behind it than what you initially might think, right? And also we want to make sure that the process is repeatable and shareable, right? If you make this fantastic plot that just works really well with how you like to show vowel spaces or something like that, you want to have that, and then you can go back to that and then do it again when you've collected new data, or you're working on a different project, but maybe there's something that's relevant. And then you can share that with other people so they can recreate your awesome plots and stuff like that. So I love that when people reach out to me. I saw this article and I really like that plot you made. Can you share the code? I'm like, yes, do it. I think that's great. So I think that's part of it that is also important. Now, aside from data visualization in general, the goals for today, what I want you to do, I'd like for you to get started making elegant, truthful plots. I think we'll get there. I want to talk about some of the pitfalls or bad practices so that you guys don't have to look back on the articles that you wrote in grad school, 10 years from now and be like, oh my gosh, what was I thinking? That's so ugly. That's so bad. Hopefully you guys can just avoid that. People are just like, oh, they've just been good from the beginning. And then I want to give you some resources that you guys can use, moving forward, 5 months from now when you don't remember half the stuff that we talked about, but you remember there was that one link with that one website that was really cool or something. I'll give you something to work with because it's a process. You can't expect to learn how to do all this stuff, especially when it involves coding in one, workshop, right? So you're gonna have to come back to this and work at it and you'll get better. I think this is one thing where everyone can get better. So when I was a grad student, I almost feel uncomfortable saying that because I was a grad student here, but when I was a grad student, I was told, and I won't say by who, that, just use a table. You don't need to make plots. You can just use a table because that's what other people do, right? The data speaks for itself. If I can see the table, then I understand everything. And I'm going to hopefully show you that that's not always the case. I think there is a need for data visualizations. So this data set here, it's a GIF, and it's just going to repeat and cycle through these images that you see in the plot. Let's just look at the images first. Bunch of cool different things. Now, if you follow what's going on over here, we can calculate the mean of X, the mean of Y, standard deviation of X, standard deviation of Y, and then what the correlation is, X is a function of Y or Y is a function of X. And what you see here is that these numbers aren't changing. All of these, they're different data sets, right? They all have the same means and standard deviations. But what you can see here is if you don't actually see the data, you might have a dinosaur there and you don't even know it, right? So think of the articles that you've read where there's only a table and you're supposed to use that table to understand the data. Do you really understand the data with the mean and the standard deviation? Not really, not always, okay? So the point is kind of silly, but there is a necessity for data visualization. It is important, all right? And you've probably heard something to this. I couldn't find out who the actual quote was from, but people say stuff like, stats don't lie, but liars use stats. Right, you can kind of fit a model to say anything that you really want to. I don't know if I'm going to offend the statistician here. No, numbers don't lie, but liars use number. There's kind of it's a variation on theme. The same idea can work with data visualization. There are a lot of ways to be, untruthful with data visualization. So I don't want you to think that just because you make a plot, that means like, okay, well, the plot speaks for itself. The data don't speak for themselves, and plots don't speak, right? And I also think it's important to make the point that it's not easy to do this kind of stuff. I talked about the Valley of Despair the other day. In fact, I think there it is, the Valley of Heartbreak, right? Again, if you know how to make plots using this, that's fine, right? That's fine. Not my jam, not my cup of tea, right? But you've probably heard about this stuff over here. And it's pretty well known, I would say, in data science in general, that R is probably the best graphical interface for making plots. It's one of the best out there. There are some other ones that can do some cool stuff. Most of them are proprietary, and I'm not a big fan of that. But if you want to do good data visualizations, usually it's done in R. So if you work in another language, that's fine. I'm not saying you have to use R, but you want to do really good ones. Whatever you decide. And also, it's really normal to be bad at first. I was horrible at first. I'm going to show you. I'm going to kind of open up the closet here to show you guys some really bad plots that I've made. And I always think about this too. I always tell my students that it's normal. You're going to suck. You'll get better. I promise. We've all been through it. Remember that as well. And another thing, I got starting off with a lot of gifts and memes here. This seems to be the case whenever you go to workshops of this type or whenever you read a book or something where it's like, I'm going to learn about whatever in R or whatever. And it's like, okay, step one. And there's a lot of hand holding. And then all of a sudden, like, wait, what? How did we get this? Got complex really fast. I'm going to try my best to avoid that. All right. You guys can tell me at the end if I did a good job of that or not. I don't know. We'll see. I mentioned before, there's a lot of different ways to make plots. You probably know, I don't know, I think this is the common one, Jamovier. We were just talking about this with Carlos before. It is an important decision, like what software, what language you're going to use to start doing your data analysis and making plots and stuff, because it's time that you invest that you're not spending on doing something else. And really, you have this kind of interesting scatter plot here where you're looking at flexibility and power, like what you actually can do with that language and that framework versus like how long it's going to take you to learn it. And R is, I don't know, in terms of like programming languages, it's not that difficult, but in terms of like, I only know Excel, it is, there is time that you have to invest before you start making really cool things. But I do think that in very, very limited time, you can get started in R making plots. It's not that difficult. There are cooler things like these here where this is kind of made for the internet stuff where the graphs are more interactive. They're made for people to, click and touch and that kind of stuff. So there's stuff out there. I don't know. This is my opinion, by the way. That's not anything um, fact-based. So when I think about data visualizations, I always like to do this kind of scatter plot thing that I do here and talk about like this weird, two-dimensional continuum of how this can work. So if we think of interpretability on the x-axis here, right, where something on the left is less interpretable and then on the right it's more interpretable. We could also think of like aesthetics, like how pretty something is, where on the bottom it's not very pretty at all, and then on the top it's beautiful and elegant, stuff like that. And then we can divide this into quadrants, right? There we go, uninterpretable, interpretable, elegant, ugly. Most of the times we start over here, right? When you're first learning something, where it's not great looking and it's not really showing what you want to show anyway. It's not helping your reader to understand your data, right? Once you start spending more time in it, you might get something over here where like, this is so cool, this is so pretty, but at the end of the day, it doesn't really help you, convey the message that you want. Sometimes you end up over here, right, where it's kind of ugly, but it gets the point across, it works, right? But clearly we want to be up here, right? That's the sweet spot where it's beautiful and someone can just look at it and right away and go, okay, cool, I get it, right? They're memorable. I think back, sometimes I actually do this a lot. I have like this collection where if I read an article and I just really like a plot or something, I'll be like, save, I'm going to come back to that. And it doesn't have to be something new and sexy or whatever. Sometimes I look back at the work of Fleggy. I'm sure you've read some of Fleggy's work from like the 80s. And he always seems to have really good plots. And I say good in the sense that they're always really interpretable, really good at like, okay, I get the message here. So think of like, who are the authors where you read this and you go, I get the message here. Start saving those kinds of things and start looking at it like, what is it about this that makes me like it, that makes it, speak to me, makes it so that I can understand it easily. All right. This is garbage. This was one of the first plots I ever made. It was for a class. I don't even know what's going on here. I mean, it was clearly, you could male, female, gender, speaker education, blah, blah, blah. Like I could see what I was trying to do here, but I don't know. I was using SPSS at the time. And I was just like, click buttons, like put everything in there and see what happens. I had no plan. I didn't know what I was doing. And I wouldn't expect anyone to, figure out what this is like a four-way interaction or something. Don't do this. No, but I'm giving bad examples because I want to talk about like, what makes a good plot, what makes a bad plot. We'll troubleshoot some of that stuff. So this is the theory part. We're going to talk about some principles of graphic design that are applicable to data visualization. Okay. And I have the little poop emoji here, and you're thinking like, what is this all about? Because it was a poopy plot. No, because there's an acronym that's actually useful when we think about data visualization. And this is not me inventing this. I'm not original. I don't know. I just do what other people do and then try to help other people learn what I learned. There's this fantastic book about design. If you're interested in that, great. If not, like I'm going to give you the core part, the craft part. So whatever. But the acronym is contrast, repetition, alignment, and proximity. And I think specifically contrast, repetition, and alignment are really like important. I think about those all the time. When I look at other people's plots, I think about these kinds of things. So let's go through this before we start getting down to it. Contrast. The idea here is that if two things aren't the same, then make them very different, right? Make it so it stands out that they're that different. And this could be something, this can be as simple as using colors, for example. I'm going to come back to, I do talk to colors right here. I just said simple and colors in the same sentence, but colors actually aren't that simple. I'll talk more about this later, but the important thing that I'll stress now that you have to keep in mind is color blindness. So something that you look at and you think it's really contrasted there, and I can see the difference here, that doesn't mean that everybody can. And I'll give you a solution to that issue in a little bit. But the idea is that there's certain color palettes in R that are already made, they're already tested for color blindness. So you pick that and you know everyone's going to be able to see, everybody. Most people will be able to at least interpret what you want to see there. In terms of fonts, usually you want to be consistent, right? If you have like a title and a subtitle in your x-axis, y-axis, like if you use bold for titles, like always use bold for titles. If you use italic for your subtitles, always use that and be consistent across like an entire article, for example, of the things that you use. Most of the times you might have restrictions with regard to what type of font you use, what family, right? Maybe if a journal requires a certain family. Those are stuff you want to look at, ahead of time, but that's always stuff that you can change if you need to. Shapes, like obviously we have a lot of shapes at our disposal for contrasting different levels of a factor or whatever. I'll come back to that as well. I'll give you an example here. The plot on the left is a plot that I consider to be quite bad, right? And then the plot on the right would be like, all right, well, let's take this and at least try to make it a little bit better. So the problems that I see with the one on the left, we have diets 1 through 4, and I'm making the idea here up, but let's just assume that really what we wanted to do was contrast diet 3 with all the other diets. right? If that was our goal, this would be a horrible plot because you can't really tell which one is 3 and which one is 4, which one is 2, which one. Exactly. If you're like me, I'm horrible with colors. You think like categorical perception or something. I don't know. There's something going on there, but like I don't know which one's which, right? But when I look at this, right, if there's two things are different, or you want people to see them as different, make them very different. Again, that's the idea here. So if I use these gray ones, I can still see what's going on. But if I don't care about distinguishing between 1, 2, and 4, then something like this can make a lot of sense, right? And then if you want people to be able to see the difference, maybe you can use contrasting shapes in the circles or something like that. But you'll see here what we have in red, I'm using diamonds, and then the other, not 3, is circles. So that's kind of an idea of how I apply that part of the acronym, contrast. Same thing, I have a title and a subtitle, like this one is in bold and this one is in like, it's like a lighter gray, or maybe, I think it's a lighter gray. So if this was for like a presentation and I decided I'm going with this kind of color scheme and stuff, I try to be consistent with all of this throughout the whole presentation. Again, these aren't rules, but these are just, ideas that you can apply. Repetition, and all of these really kind of go together. Repeat themes throughout a document, a presentation, an article, whatever it is that you're showing to people, right? So I usually, for an article, I'll pick a color palette and then I'll stick through that with that for everything that I go. So like if I have a certain color for a level of a factor, for example, let's assume I have a grouping factor that's like bilingual and monolingual, to say something. I'll try to use the same color for bilingual, for example, all through an article. So people know, they come to the next one again, and it's unconscious. They're not thinking, Joseph chose red for the bilinguals again. No, it just happens. You see that, and they know where to go, and people remember these things a little bit better. I mentioned color palettes, fonts, other things. It's like these things apply to different areas, right? But there are also other graphical elements like alignment, and I'm going to talk about that one. I think it's next. Yes. So when you're looking at a page, this is, again, graphic design type stuff. This is probably more important for when you're making posters, because with articles, a lot of times you'll send it one way and then the copy editor changes it. You have no control over that. But thinking of when you have to do like a poster presentation, for example, if you can, you want to justify things in a way that makes it easier to read. This, for example, to me, this makes me nervous. This is chaos. I see this and my heart starts beating faster, and I'm like, eye twitches. I don't like this at all. And specifically, why is it? Because there's a lot of ways that we could align this. It just makes it easier to comprehend. It just makes it easier to read. So, for example, in this example, what we could do here would be just justify things in a way. Typically, if I have like a table, I'll write justified numbers, and anything that's text, I'll left justified. It makes a nice separation that's easier to read. The same amount of decimal points if you have them, if possible. And again, sometimes those things, like I'll spend a lot of time working on tables, not just plots, but also tables. And then I'll send it to a journal, and then they do whatever they want with the tables. It's like, man, I think that's probably why I started using plots instead of tables to like represent the same information. And then I put the tables in the supplementary information. I'm like, you can do whatever you want with them there, because no one's going to see them. But whatever. Proximity, things that are similar. You can group related things together in a way that makes sense depending on what you're doing. So this again has to do with the focus on the document layout. Sometimes I think that this is less applicable to data visualization. It's more about like the tables and stuff, but it's part of the CRAP acronym. So I would feel like I'm not doing the book justice if I don't mention it. But like I said before, I think the first 3 are the ones that really will help us. Okay. How are we doing so far? Questions or anything? Cool. All right. So even if you are not artistic, even if you don't have a background in your graphic design or whatever, you can learn to craft. Anyone can do these. These are that simple. And it's just practice over time. You will get good at it. You'll start to see it in other people's plots when they don't do it, right? You just start to develop that kind of eye. I want to give some examples of like the main types of plots that you'll normally see. So that was actually in the Slido, that was something that came up, like kind of knowing like, well, if I have this type of data, what can I do with it? Right. And I think that's a big part of it. Like when I first learned like when and why I can make a scatter plot, it sounds so dumb to admit, but I was just like, oh, wow, scatter plots are my favorite. But anyway, I'll go through and talk about some of these. I dislike a lot of them, and I'll tell you why, but that's subjective. I think a lot of times data visualization, it's a lot like art, like I can tell you what I think, but that's just my opinion, right? So we'll go through. I assume you've heard of all of these. Are there any up here that you just don't even know what it is? No, we're good in that regard. Cool. So I'm preaching to the choir. I don't like pie charts. And I would say there's really no reason to ever. Sometimes I'll do like the donut plot kind of thing. It's really similar to a pie chart, but they do studies on this type of stuff. And it's just really hard for people to look at a pie chart, for example, and distinguish between like 60% and 50%. And that could be, well, maybe not 50, but 60 and 70. I don't know. Sometimes there can be differences that are really important, especially if you have a lot of different levels inside of what's being, like a lot of different colors. So I would say avoid pie charts like the plague if you can. You can. Yeah. Bar graphs. We've all seen bar graphs. I really dislike bar graphs as well. They do get a lot of hate. I think there's a place for them. I think sometimes they can make a lot of sense. What I really don't like, and this is a good example of it. What are we looking at on the vertical axis here, right? Percent correct, right? And then we have two groups on the horizontal axis, monolinguals and bilinguals. This is just made up data. I don't know. People might get mad, whatever. Why do you think this is bad? The scales. Yeah, you don't know exactly what it is. It could be off. Yeah. Were you going to say something? You can't tell exactly what number. That's one. That's a good thing. I mean, sometimes you only want people to just see that there's a difference, but that's more like qualitative, like yeah, maybe in a presentation, but like in an article, I would say like you really never need to do this. My main qualm with this is like there's no measure of spread, right? I can't quantify uncertainty when I look at this because it's just giving me one value. But it's very clear to me that there has to be uncertainty in this because it's a percentage of something. It's not a count, right? I would say that there is room for bar graphs. I said people hate on bar graphs a lot, but sometimes they make a lot of sense when you're counting things, right? Where like 90 means that you counted this and it occurred 90 times. And it makes sense to have a bar graph for that. But if you're calculating a mean and there's a standard deviation, for example, this doesn't help me, right? What this is telling me right here is like, what does all this mean right here? Right? That we counted up to that? No, what we calculated is right here. And it's just a point. A mean is a point estimate, right? And there's a measure of spread that goes up and down, right? But we don't see anything at the up. We only see something at the down. And you can say, oh, well, you can put error bars in a bar graph. That is true, but it still doesn't account for the fact that this is like assuming that there's something there when there's not. It's kind of weird, right? But when you count things, that could be the case. So, oops, went too far. So people like, they make fun of this a lot. They say, no, don't do bar graphs. You should do something like a box plot, right? And that's probably a good example. I actually don't even like box plots that much, but they are good. You'll see these a lot. Next up, box plot. This is better, right? Because I have a point estimate. And I have several measures of spread, right? I have several ways of quantifying uncertainty because I can see whatever this is here, whatever this is here, whatever this is here, whatever this is here. And then sometimes you'll see outliers, pointed on there as well. Does anyone happen to know what these things represent? Statistician? Do you? I thought I put it in here. Did I not put it in here? Oh, I didn't put it in this. I could have swore I put it in. Wait. I'm going to go forward just because I mentioned it. Now I can't not have it in there. There it is. Where'd it go? I just saw it. There we go. I clearly in my mind, I was planning on doing this later in the presentation, but since I mentioned I have to do this, if someone ever asks you like at a trivia night or something, you have the first quartile, the third quartile, the line is the median, and what determines if it's an outlier or not? We have quartile 1 minus 1.5 times the interquartile range. It's chaos. Nobody remembers that, right? But you see it and you go, oh, maybe if it's beyond this, it's an outlier stuff. But anyway, let me go all the way back to where I just was. Yeah, there you go. You remembered some of it. That's good. So I think these are fine, right? These are fine. I personally, I don't like these because I prefer to see the raw data with a point estimate. And I'll get back to that maybe in the next slide. I don't remember that. We'll come back to that. We good? Yes. Yep. I love that. I think that's good. The more information that you can give, the better. At the end of the day, when you think about like, well, what is the purpose of doing a box plot? Usually you want to give some type of point estimate. In this case, the line represents the median, but you can also plot the mean as well. And then in some way you want to quantify your uncertainty, right? And if you can do that, and you can do that better, good, right? The only thing I would say to criticize that, I want to see the raw data too most of the time, right? You would overlay a violin plot and then a box plot on top of that. A violin plot is different in that it shows the distribution of the data as well, not just a point estimate in a measure spread, right? And pretty sure I'll show that in here in a bit. And if I don't, then we'll do it when we start playing with R. Okay. Cool. Was that Sabina? Okay. Histograms and density plots. I love these. These are my favorites because you can see more or less where a mean, median, or mode might be, and you also see uncertainty in a measure of spread. The way that these work, if you don't know, it's just basically you just count things, right? So you have, in this case, I played this with Lextail data, where all of these are possible scores on the Lextail, and then every time 50, for example, pops up, and you count it, and you count it, and you count it, and it just goes up until you have that. And then the density plot is basically the same thing, right? But it's a probability. Yeah, I'm a big fan of this again. Yeah. We'll talk about how to make those and how to make them pretty as well. Good. No, my absolute favorite is the scatter plot. I think these are the best because you can do a lot with these. Basically any regression model that you're doing, and most of the time we're doing regression models, you can fit a line through it. That's what a regression model is, right? You have a cluster of points and you're tossing a spear through it. We're barbarians and we understand lines really well. Once things start to curve, we don't know what's going on, right? 2 dimensions with a spear, we've been doing that for a long time. So you have continuous variables on both axes, right? So you can put a point where one corresponds to both of the predictors or variables and then you can see the data. You can see the raw data. So you can put here all your points, but you could also fit a line. So you can show a line of best fit with a measure of spread around that. For me, that hits all the bases. That's the way to go. And we'll talk about how to make these better. Heat maps. Heat maps can be kind of difficult. They can be tricky. I like them, but they can be tricky. This is from, I think this was my first publication, an article I did with Mikhail, and it included a heat map. The idea here is maybe you have 3 continuous variables, and once you start getting into 3-dimensional space, people can get confused. As humans, we're not good at that. And if you have more than 3, we're in trouble, right? So here you have continuous variable on the y-axis, on the x-axis, and then color is mapped to another continuous variable. So the darker it is, right, the higher it is, the lighter it is, the lower it is. And I like this because this type of stuff is hard to do. People usually don't interpret this the same way, but this is this right here, right? Put in a 2-dimensional plane. This is it in 3 dimensions. I really like this because it's like, it looks cool, but it's not the best for an article because when I see that, I want to take it and spin it and look around it and do all kinds of fun stuff. And you can't do that, or at least not in an article. You can do that online, right? You can create ones with like the D3 package and you can click it and move them around. So I don't know if I have an example of that in here. I should put one in, but you can do that. It is possible. Yes. The one going up and down here is this color. Yeah, well, actually, these were computed, not in the same call. So the color like this is actually kind of darker because it doesn't show it as darker. This corner right here corresponds to this corner, but it's like you'd have to look at them independently. But what you do see is like as you come over here, this is a little bit darker than over here, and that's why this part is higher than it is over here. But it's like I ran out of spectrum for it to work on this. Yeah, if that makes sense. Yes. And in this case, what does it mean? Like the interpretation here. So I did it was a categorical perception type experiment where I manipulated its spectrum. It was like a sheep-ship contrast. And not only is it the spectral envelope, but also the duration of the vowel. So the continua for the duration is here, the spectrum is here, and this was the probability of selecting sheep or something like that. Right. So the darker it is, the more likely they were to say sheep versus ship based on what stimuli from the continua, what step it was. Right. Does that make sense? Yeah. In any case, you can see why it's troublesome. Like you can't just look at it and know. As well, yeah. It's double. Right. This could just be completely white. And as long as you see like the wireframe, then you get the idea, right? Exactly. When spectrum is high, right, and duration, it doesn't matter, this is high. And if you go up spectrum and it's high, these are all dark. That's the same thing. But here, I tried to map the color on here, but I ran out of spectrum then. If I could redo this was in 2015. If I could redo this, I would definitely rethink the color part of it. I was just a kid, just a puppy. Yeah, I didn't know any better. But like I said, I'm showing you all of my sins. This is maybe a better version, I guess. It's the same idea, but with more factors. So it's like you can see it like just one of these is like enough to make you kind of go cross-eyed. But obviously, we had a lot of different factors here. So we're looking at the continuous variable, right? Where we had a z-score for exposure on the horizontal axis, a z-score for proficiency, and then a darker was the probability of fixating on a target. This is from an eye tracking study, but we also had different groups. So I tried to get everything in one, and this is a way to do it. The reviewers actually like this, but I come back to this and it takes me like 10 seconds to remember what exactly I was trying to do. It's not one of those where it's automatic and you can see something, right? But we had different types of learner where we had Mandarin was their L1, English was their L1, they were learning Spanish, and then marginalizing across learner groups. And then the same thing for the type of word they were hearing, if it was paroxytonic stress versus oxytonic, and then marginalizing over stress. And then same thing here. Lighter color was a higher probability of fixating on a target. So the opposite of the one I showed previously, and then a lower color here is, a darker color is a lower probability. So you can do that. You can work with 3 dimensions or 4 or 5 different factors, but it gets sticky, right? It gets kind of hairy. Did you have a question? Yep. Mm-hmm. Could be a problem. Very true, especially this type. So a lot of times, some of the packages, the color palettes that I'm going to recommend that are colorblind safe, usually will convert to grayscale in a way that is acceptable. But that's something you should always check whenever you're finishing up an article. Another alternative would be just go grayscale from the beginning so that you know, right? But I don't know, that's boring. No, leave that up to you to decide. But that's an excellent point, and that's very important. Every article I do know, I always print it and I always look at it first in grayscale to see how it maps. And usually, if you can, in this case, it doesn't work well. But in other cases, for example, if you can also use like a shape and you can differ in shape as well, then it doesn't matter. Yeah. So sometimes you luck out depending on what your data looks like. So heat maps can be fun. Okay, that was the heart of like what you're going to see typically in any given article. There's some newer, cooler things that pop up every now and then, but these are like the most important ones. Any other comments? Everyone good on that? Cool. So what I'm going to talk about now, the grammar of graphics has to do with a plotting strategy specific to R. Well, not necessarily. It's a plotting strategy specific to programming languages that has been adapted and worked through in R. Have most of you heard of ggplot before? Tidyverse, all that good stuff. If not, that's fine. You're going to see it. I'm probably preaching to the choir at this point for some of you. It's actually super interesting. So the grammar of graphics comes from Wilkinson, just thinking of statistics, computing, data visualization in general. And then Hadley Wickham, who I'm going to talk about in just a second, is the author of ggplot, kind of applied it to this package that you can use in R. And the idea is that we're always doing the same thing when we're making plots, right? We have data and we're trying to map it in some way to some aesthetic feature, right? So remember these terms, data and aesthetics, because we're going to just keep coming back to that, okay? So what is data? When we're talking about a grammar of graphics, data is a column in a data frame. A data frame could be an Excel sheet, it can be a CSV, a TSV, et cetera. I almost always just work with CSV files, right? So you're just talking about some kind of tabular data. Tab separated values. So sometimes what separates numbers is like a comma. It can be a tab. It really can be any character you want, but those are the 2 most common, right? I like have this disdain for Excel or anything Microsoft. So like I would just see CSVs for everything, if possible CSV, but it doesn't matter. It's irrelevant. So that's what we're going to consider data. What are aesthetics? In this case, it's a visual property of the plot. It could be a position, an axis, for example, the x-axis. It could be a shape. It could be a color. Now, whatever thing you need to use to map your data to something visual is what we're going to call an aesthetic. So depending on the type of data that we have, we'll pick a different type of aesthetic mapping, right? So as I just mentioned before, you've probably heard of the tidyverse in R. It's this multiverse of different packages that all use kind of the same grammatical syntax or whatever for how you program things. And ggplot is just one of the packages in this little multiverse of R packages, and they all follow kind of the same ideas. And when we're thinking about ggplot specifically and how this works in R, well, we have basically layers. We think of it as like, I don't make cakes, so I don't know why my brain went to this metaphor first, but I think in cakes you do like layers on a cake, right? You can? Okay, so when we make this cake, we're thinking of as layers. So you start with one thing, you put it there, and then you put something on top of it, and then you can add something on top of it. It's very modular in that sense. There's got to be a better metaphor out there than that. What else do we do with layers? Oh, there you go. It's a lasagna. Ah, yeah. A bed, yeah. Pick your favorite metaphor. I'm gonna go with what did I say at first? Cake. I'm gonna go with cake. I don't know. I don't even eat cake. I hate cake. Oddly enough, but cake. Um, but you can see some examples of what we see. We start here with data and then aesthetics. These are the two that I mentioned, right? We're gonna get into geometries, but there's a lot of other things here, right? But the idea is you do one thing and move on to the next. Okay, so here's how this works in ggplot. I mentioned before it's written by Hadley Wickham. I always mention this when I talk about this because I think it's crazy because he did this when he was a graduate student, right? What have we done as graduate students? This guy wrote ggplot. I made the worst plot in the world. Yes. Anyway, the idea is that it's a way to simplify all of these kind of difficult choices that we have to make when we want to make an elegant plot. For example, it deals with things like spacing, text, titles, all of that automatically and in this way where you're just adding things to it. Oh, you want to put a title on there, add one more thing. You want to put this on there, add one more thing. And it's easy because you build things up in layers. You can start with something really simple. In fact, every plot I ever make, it's like 3 lines of code. Like, okay, there it is. And then you start tweaking, and then all of a sudden you've got something like this. It's kind of fun, but that's how it usually works. So you'll plot the data, and then you can overlay some kind of summary if you want. It could be a mean and a standard deviation, whatever you choose. You could put metadata, annotations. I do that a lot more now, especially when you have like annoying word counts in certain journals. You like to put as much words as you can in the plot, and they don't count. There's all kinds of fun little tricks. The components that we're going to use when we do this, we first of all, the starting point is always a data frame, and we'll see that as we go along. After that, you're going to choose whatever aesthetic mappings you need, depending on what you want to convey, depending on what kind of data you have. You'll pretty much always have coordinates. Sometimes it's just an X or just a Y, but usually it's an X and a Y. And then you can make decisions about, do I want to use color? Do I want to use size? Do I want to use shape, etc. There's a lot of choices here. Geomes, this is a newer one. We haven't talked about this yet. It's that represents geometric objects. For example, like points, lines, box plots, violins, whatever you want. For me, points and lines are the best. I think it's like the simplest. When you start getting the other crazy stuff, sometimes it can get messy, but you know, there are good choices other than those. I just always go to those first because I think they're the traditional ones that work the best. All right. There's also stats or statistical transformations. I'll leave it at that for now. Come back to that. And then we can also make facets, which are panels, like when you see multiple plots together, faceted in some way. This is all part of this this grammar of graphics. And we're going to basically be able to do all of these things in a framework that's simple, it's intuitive, and after a couple minutes of practice, you can do it quite well. All right. I don't know if I mentioned this before, but I'm just kind of assuming that you know nothing. So if you know a lot or a little whatever, yeah, that's the way to go, right? So, So going back to this plot that I showed you at the beginning, now we're looking at this full screen, and we're going to go through and talk about this grammar of graphics with regard to this specific plot. So the first thing that I would look at is like, okay, I always start with the dimensions. In fact, whenever you're presenting, this is just personal advice. This is what I tell my students all the time. They probably think I'm like, whenever you're presenting, like the first thing I do is go, okay, on the vertical axis, we have, and walk your person through it because they don't know. And sometimes when something pops up like this, it's just a lot to take in. Like hearing someone just hold your hand and say, okay, on the vertical axis, we're looking at weight. On the horizontal axis, we're looking at time. And I say that with every plot that I ever show. That's how it goes, right? And then I could say, we've mapped diet number 3, right, in red, to the diamond shape, and then blah, 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 right? So just walk people through it. Now, if we think about this in terms of the grammar of graphics, we can see I mentioned we had time, right? That's an aesthetic on the x-axis. In terms of geometry, we look at points and lines. We have weight, that's y-axis. In terms of geometric object geometry, that's points and lines. We have, in the data frame, we also had chick, right, which represented which, I think it was it, let me go back. Each chick, yeah, no, each line represents a different chick. Let's talk about the data first too. So they have all of these little chicks, and they were giving them different diets to see how that affected how much weight they gained over time. Okay, that's probably important to mention at the beginning. So in the data frame, chick is another column, right? So in this case, it's represented by points and line, or the aesthetic was points and endpoints and line. And then diet, which is kind of like our categorical factor here, which in this case, we see colors and shapes, which is the aesthetic, and it's mapped to points and shapes. And in this case, I made the decision to kind of marginalize across 1, 2, and 4, right? And just highlight too, but that was just to make a point. That's not anything relevant with regard to chick weights. I don't know anything about chick weights. Okay, so that's kind of how that works. Now, in terms of syntax in R and what this looks like, right? We can map those things to a very common syntax so that we're always repeating the same type of thing. So in terms of the aesthetics, right? Before I just called it aesthetic. In ggplot syntax, you see that as AES, that stands for aesthetics, and then open close parentheses. So all of these things will go inside of that, right? So we have an X, a Y, color, and shape. It's really straightforward. In terms of the geometric objects, it also follows the same syntax. We'll see geom underscore and then something else. So in this case, we saw geom point and geom line. There are other geoms you can imagine: geom box plot, geom violin, geom. I don't know, nothing else comes to mind right now. There's probably more. Those are the main ones. All right. We're good? Cool. So here's a template. This is a simple template that I would recommend that you start with if this is new to you. And I'm going to go through kind of line by line and show you what these things mean. And then I would say, like, I don't know if you can copy and paste it, save it somewhere. And every time you need to make a plot, start with that and then start working through it, right? But what you can see is we have inside of a function called the ggplot, we open parentheses and then close parentheses down here, right? We have an argument that's data, right? So this will always be a data frame, right? It's right here. Data frame will be replaced with your data frame, whatever your data frame is called in your data, and then some type of mapping, right? Where in this case, the mapping argument is calling the aesthetic function, right? And in here, you will replace it with whatever aesthetics you want to do. So like by default, it'll almost always be X and Y, right? You'll put something there, but there can be added stuff as well. We close the parentheses on the function called the ggplot, and then we start building up layers, and that's what this plus sign is for. So we're saying, okay, this is our base plus whatever we want. In this case, I say geom underscore xxx because it depends on what you want. We can do this with geom point, for example. ggxxx will be replaced with any specific geom that you think is relevant. When I start at this point, when I'm making a plot, usually I'm thinking in my head, what do I want here? What makes sense? This is what I have. Where do I want this? Where do I want that? And sometimes it's just trial and error. Like throw something in there, it breaks, it doesn't work. Okay, I try something else. Okay, now I got something. Okay, this works, but I have to rethink this. Maybe you switch what you have in X and what you have in Y, something like that. But usually there's a lot of trial and error going into it. As you go along and you get better, you just know. You see what type of data you have. All right, continuous variable. Okay, scatter plot, boom, right? Pass it. You'll just get a lot better at it as you go. So this is our template. Everything I show you from here on is going to use that template, right? And of course, we need data. It starts with data. So I'm going to show you a little bit about this data frame that I'm using for all of the examples. If you're following along in the WebR thing, this will load for you. If you've copied and pasted the script I showed before and put that into an R Markdown file or an R script, right? And then one of the first lines of it will download this data from this URL, and then it'll load it into R. Okay, that's whenever you do workshops like this, like sharing data and getting people to just load data into R, sometimes it's like the biggest hassle. This simplifies that. It's just a link and loads it automatically. So if you're doing this, following along, do that now, specifically if you're working in an R script. If you're using WebR, it'll load for you automatically. Okay? Did anything break yet? Does anybody need help? Yep, exactly. I say now what you can do is you can use this function called head and then put inside of that new data, send that to the console, and it'll give you information about the data frame. And you can also try summary, new data, and that'll give you a 5-number summary about the data as well. If you're using WebR, that code is already written for you. You just have to click run, and it'll do both of those at the same time. You can see it. Go ahead and do that now, and tell me about it. What did you learn? What I do say that a lot. I do say that. What kind of information did you see in the console about? No, I don't want to avoid. I actually like it. What do we know? What is this data frame like? Yeah. What do we have in there? Yeah, anybody? Object what not found? Object link. So oh, wait, did you run this part first? And it said, did anyone else look at something? Okay. Okay, no, think about it, do that. I'm going to actually come up and look. Oh yeah, I see it on here too. So um, yeah. Okay, so what do we know about this data frame? What does it look like? What are our columns? Right? What is that column called? Group. We have okay, column called group. What else? Okay, cool. Okay. I'm not asking as like a fake question. I really don't remember. I probably put it on here. Yeah, there it is right there. No, it wasn't. I really wanted to know. Okay, so we use head and it just gives us the first six rows. We can see we have one column called score, another column called proficiency, group, bilingual, model, or whatever, age, older, younger, older, young. Okay, cool. We've got some information. This is fake data. This isn't from a study or anything. I just made it up. So I thought, okay, this will work. Yeah. Yeah, that's a good point. So with head by default, it just gives you the first six rows. But if you want to look at more than that, you can put like n equals and make it longer. Yeah. Or you can use what probably is a better idea. And I didn't do it here because it works. It doesn't work really well when you do it in presentations. If you type in view in our studio with a capital V, it'll open it up like it was an Excel sheet in a separate window. And that's usually, did you do that? I think I saw that on your screen. Yeah. That can make it a lot easier because you can scroll up and down and look at everything a little bit better. Yeah. Yeah. If we do the summary, I actually never really use this function, but it's kind of cool because any continuous variable, it'll give you the min, mean, max, blah, 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 blah. If it's a categorical one, it'll give you information. In this case, it's character, but it'll say, oh, there's this, blah, 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 32. Age it's in there as a factor, so it tells you how many there are for each level. I had young, older, and oldest. I didn't want to offend any of the old dogs, older, oldest, whatever. So this is what we're going to work with, and we're going to let's try to make all of the different plots that we've seen, or at least the good ones, right, using this data set. And I do it in a way where I show you like the basic, like here's the template, here's like the first draft of what you do. And then as you get more involved, there's little tricks and stuff that you can do to make them prettier. Yep. For whatever reason, this column is being read into R as a character vector, and this one as a categorical factor. You can change that. It's irrelevant. Yeah. Yeah, no, that is weird. By default, why would I do that? I guess when I made the fake data, I saved it as an RDS file. I showed that on the previous one, but you see the ending right here, it's an RDS file. And RDS files maintain the structure of like what each column is. It doesn't just try to guess when you wrote it. And I think when I made it, I just saved it that way on accident. No, that's a good question. That's a good question. It seemed kind of weird, right? In a perfect world, these would both be factors, but you can change that. No big deal. All right, we good? All right, let's go. So let's talk about aesthetics, the aesthetic mapping. Again, you always see this as a function AES, open and close parentheses. Aesthetic mappings. How do we map data to color, size, axis, whatever we need? Always remember that we map data to aesthetics, okay? So we're going to update our template by adding these things in, right? So I put it kind of darker, but you can see the important part of what I'm talking about in our template. I put in proficiency on the x-axis because I arbitrarily right now decided that's what I want. And then I put score on the y-axis. If I send just this to the console, it'll spit me out a plot like this, right? By default, ggplot uses this gray background with white grid lines, which I hate, but this is the default. It works. And I mean, it's not bad. I don't know. I want something different, but whatever. You can see that it did work. It mapped score onto the vertical axis here, and it automatically chose a scale for it from 0 to 100, or 0 to 1, excuse me, because that's the limits of what's in the data. And then on the Y, or the x-axis, the horizontal axis, it mapped proficiency, which is what I said, and then it automatically picked a scale as well. As you can see here, it has 2, but it doesn't have 2 on one end. It's just because that's what happens to be in the data set, right? I can control that, but by default, that's what it does. Right? And this is a pretty good start. Is everyone able to send this right here to the console and see something? If you're using WebR, I don't think I put that there by default. I'm just asking out of curiosity if you're playing around. Okay, yeah, I put the geom point after it, which I think is the next one. Yeah, here we go right here. Okay, so again, just using aesthetic mappings is cool because it shows an example. Hey, we're getting there, but it doesn't help us, right? So we have to add a geometric object. In this point, I start with geom point. So make sure if you're typing this on your own that you put in the plus sign, right? Because we're adding a layer to the lasagna, right? And then there are a lot of different types of geomes, right? I mentioned before like three, and I couldn't think of any other one. Geome smooth is another one. Geome hist for histogram, geome bar, geome box plot, et cetera, et cetera. A smooth is one, it's kind of like taking an average as it moves along across one of the variables, right? And I'll show you some examples of that. You can use that to fit a line, for example. All right, so if you were to add point to what you made before, then you should have a scatter plot. Apparently, I didn't want to do that. I just want to talk about it. I'm going to do that in just a minute. All right. There we go. I mentioned also you can have a statistical transformation. That's usually stat underscore something. In this case, stat summary. This is one of my favorites. I use this literally all the time. If you've never used this, I recommend that you put this into your toolbox, right? Because this one is really good. It will calculate a value for you, and you can choose what that value is. Sometimes that'll be a mean. Maybe you prefer a median. It can be a bootstrap mean with a standard error. There's all types of fun options, and it'll overlay that on top of whatever layers you have already put in your lasagna, right? So in this case, what I did in my example is I replaced geome point, and then I just put in the stat summary on top of the initial call. This one has some other arguments. Now at this point, you might start seeing, okay, you tell me stat summary, that's good, but then it's got all these other things. How do I know that, right? And this is one of the difficulties when you start doing this kind of stuff, and it can be completely overwhelming because every function has arguments, and you don't know by default what the arguments are. Right now, I'm telling you some possibilities. In a bit, I'll show you how to find this, right? It's not difficult, but you know, take some thought. So in this case, there's an argument called function.data. That's what fun.data. It's fun, right? No, but that's for function. And I'm saying use the function mean underscore standard deviation. I don't remember what the L stands for in this, but in any case, it's going to calculate a point estimate of the mean, and then it's going to give me a measure of spread, in this case, the standard deviation, okay? Or two standard deviations. And then I can say what type of geometric object do I want to use to represent this, and I chose point range. That means it's going to put a point and then a line representing the range of the standard deviation. You can do something completely different, but this is just what I chose. If you're playing along and typing this out, you can do this, and you should see something. Or maybe not, I don't know. It doesn't matter at this point. I'm just giving you examples of what these look like. Now we're going to actually play with it, and I'm going to put the plots in here, okay? So let me take a second, step back, pause, ask, how are we feeling? We're feeling okay. Is it the case that this is still pretty elementary for most of you where you're at your levels? Like you're like, okay, yeah, I know this. Not everybody. Okay, perfect. Then I'm glad I'm taking it slow. All right, so then now we're going to start walking through. We're going to play with some actual plots, all right? So we're going to revisit mainly these four. And like I said before, we're going to do the beginner, intermediate, advanced examples of this. And I think at the end, I even added a cooler one that's, I don't even know if I put the code, but it's one that I really like. Okay. So we'll start with the histogram, if I'm not mistaken. If you're following along in the web presentation and not doing anything in R, you can just click the thing here and it'll show you the code for each one on the left and then the plot on the right. If you're doing it in WebR, you just click run code and it'll do it for you. And you can click the pestaña, the tab, right, for beginner, intermediate, right? So we'll start here. And I'm actually going to run through this and talk about each line of the code here to kind of explain my thinking and what's happening. Notice that if I have the hashtag, anything that comes after that is a comment. And I always comment my code. You should always comment your code, mainly because if other people read it, then they'll kind of understand what you're thinking, what you did. But also because 6 months from now or 6 years from now, you come back and look at your code and you will not remember what you did or why you did it. And every now and then you'll figure out some cool solution to a problem. You'll be like, oh, this is awesome. And then you'll come back and look at it. You won't understand why the code worked or why you did it that way. If you leave comments, it's just a really, really good habit to have. In this case, I'm just saying what it is. It says continuous variable on the x-axis. There's nothing mapped to the y-axis. And the way we see this, we have our ggplot call. Our data is new data, right? Like always. Our mapping is just one aesthetic right now. In this case, it's x is score. So we're putting the scores for whatever that represents in the data set on the x-axis. And then we close our ggplot call. We add our layer to the lasagna. And I want, in this case, geome underscore histogram. All right. And as you can imagine, what that is going to do is going to make a histogram for us. So what you see on the right is the histogram that you get by default, right? With the gray background and the white grid lines, and then it puts the histogram that counts here in I guess it's black, right? But it picks, whenever you make a histogram, it does different bin sizes. It picks a bin size by default. If you're running this in WebR, does it give you a warning like we chose 30, a bin size of 30 or something like that? Does it say that? Okay, this is an important point that I asked that question because I wanted to make this point. By default, it has to make certain arbitrary decisions for you, right? When you first just make a plot, you're just happy to make something, but sometimes those decisions aren't the best. This is not a great histogram, right? You can't really, it doesn't look like histograms that we typically see, and it's because maybe it's not the most appropriate bin size. Sometimes that's just trial and error. Let me see, was there more? Yeah, so the histogram call gets that. If I go to intermediate, this is when I play with that a little bit more. So let's look at what I did here just to change things up a little bit. It starts out the same. Well, actually, no, I do. So in beginner, let me explain this because you're going to see that in the code. In beginner, I use our template and I just do the most basic thing. When I actually write code in ggplot, I don't usually do it this way because a lot of these arguments you don't have to express explicitly because it's just implicit and you know that. But I put it there so that you understand the idea of we're mapping data to aesthetics, right? But when you look at intermediate, you won't see that there. I put the new data, the data frame call just right into ggplot, and then I have aesthetics in another line. And you might be like, this is so confusing. I did it this way on purpose because you're going to see it both ways. So I want you to get accustomed to understanding that that does the exact same thing. All right. Let me repeat that just to make sure that's clear. Lines 2 through 5 in beginner are the same as lines 2 and 3 in intermediate. Okay, it's just more succinct. And you could make it you could make it a one-liner if you want to. I just chose to do it there so you see a little bit of variability. Variation is great, right? So, anyways, so again, we can see that we've mapped X to score, or score to X, excuse me. I call my geom histogram call, but now I have arguments inside of geom histogram to customize it a little bit more. Specifically, I picked a color, black. When you're looking at a histogram, color represents the outline of the bars. I picked a fill, gray 70, and that represents the inside of the bars. You can see that color change. And then I selected the bin size. By default, it selected 30, and we saw that that wasn't that great. I changed the bin size to 9, and I go, okay, now it looks a little bit better. All right. There is kind of like some theory behind how you should select your bin size. I don't remember what it is. There's like 1 point something times blah, 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 and it'll give you an estimate of whatever it'll be. I always just play around with it until I find one that I like. You can do whatever you prefer. Exact. So it means kind of like the width of how many things are. Actually, you can do bin size and you can also do bin width. Bin width means specifically the width of the bin. So it could be like from 0 to 3 is 1 bin, and everything that falls within 0 to 3 you count. Bin number of bins means there's 9. 1, 2, 3, 4, 5, 6, 7, 8. Right. So you can do it either way. I find it to be more intuitive and easier to just pick the number of bins, but you can do whichever way you prefer. Was that your question as well? Okay. All right. In the WebR, is there an advanced for this or just in beginner and intermediate? Okay. Any questions on that? Now, one thing that's cool about the WebR one is that you can actually type in there if you want. You can change the bin size and rerun it and see how it changes in real time. If you prefer to do that, I encourage you to do that. Go ahead, break things, and then you'll reload it and start it over again, whatever. Any questions about histograms? Histograms are your friends. Get comfortable with them, use them whenever they're appropriate. Yes. Oh, I did not. Thank you. I told you that I hate the gray background that ggplot gives you by default. You can change that whenever you want. There are thousands of themes. You can make your own theme. You can download new ones in different packages and stuff. One that I use quite often is theme_black-white, right? Where it gets rid of that gray and it kind of reverses it. Now the background is white and then the grid lines are gray, right? And inside of that, I can choose the size of the font. If I go back to beginner, you'll notice that the font size is, it's all actually pretty much the same. Oftentimes, whenever you scale up to a presentation or you save the figure, you'll see that the font sizes are really, really small. So this is where you can control that. Base_size is the font size. And then base_family is the font type. The one that it picks by default is kind of weird, but I really like the Palatino one for whatever reason, but you can pick times or whatever you prefer, right? Or maybe whatever a journal makes you use or something. But I just wanted, the point of this was that to show you that you can change these things, right? Not necessarily that this is a good one or that this is the best or whatever, just that this is a possibility that you have at your disposal. And it's really easy, right? It's just a couple of lines of code. Also, this is probably worth mentioning. What you see here, whenever I have one of these layers, I'm putting different arguments on separate lines. That's just so it's easier for you to read. You could put it all on one line and make it wider. But to fit it into this narrow space right here, I just, separate lines, and it doesn't change anything. Those what? Yeah. No, I didn't do that myself. The program that I used to create the presentation, it's a reveal thing that I did in R. It does the syntax highlighting for automatically. Yeah, it's really helpful, right? Because anything, I'm glad you said that because let me mention this as well. Anything that you see in blue is a function. Like R, the syntax represents that it's a function, so it puts that in a specific color, so you always know, okay, this is a function. Anything that you see in green, like light green, whatever green that is, that means it's an argument of a function. Okay, and then anything you put in parentheses, right? It gives you a different color as well. What's that? Well, yeah, what did I say? Yeah, quotation marks. I'm just confused. I mean, I know what it is, but I say the wrong one. Yeah, anything in quotation marks, it's a different group. Okay, are we good? All right, I'm going to move on to the next one then, I think. Is that what's next? Scatter plot, my favorite. So, again, walking through this, we're starting out with the template, same thing. The comment here is we have continuous variables on both of the axes. So whenever you have two continuous variables in your data, then you have the possibility of the option of making a scatter plot. I encourage you to do that because it's cool. Data, mapping it to an aesthetic. So our aesthetic here, now we have two of them. We added a Y, right? And both of these are continuous variables, okay? We'll keep going. All we have to do to create the scatter plot then is add a geometric object for points, geom_point, and this is what it will produce for us. Okay, if you're in WebR, you run that, you should be able to see that. If you're typing in code, let me know if you get any errors. So by default, you don't need anything, but you have to put the parentheses there so that R understands that it's a function. But that means that lets us know we can put things in. And I think that's what I'm going to do right now. Actually, you're giving me all these perfect ways. All right. So let's move to the intermediate one, and you'll see that, okay, now in geom_point, I'm putting more things. Now, what did we do here? We made it maybe slightly better. I used a different theme again. I did all kinds of weird stuff. Let's take a look. ggplot, I have the data frame. I'm putting the aesthetic mapping in a different line in its own function, not inside of the ggplot call. It's the same thing, just like I said last time. So we have proficiency Y. These are the same as before. Now, if we go to line 5, I have my call to geom_point because I want to put points on here. But I added another call, aesthetics function call here, where specifically I'm saying for the geom_point, the color is going to be green. Okay, green, sorry. Color is going to be mapped to group, the grouping column in the data frame. And that means if we looked at it before, we know that group had two levels, bilingual and monolingual. So by default, R selected two colors, and it's representing those in the scatter plot. So the light blue color here is monolinguals, and then the red color is bilingual. So I think that's right, right? Now, I made a choice here just because I'm doing things differently all the time and stuff, but I put this aesthetic call inside of geom_point on purpose to show you that you can do that if you want to. Just as easily, I could put that up here inside of this one, right? And just put a comma right here and add that right here, color equals group, and then I could have saved some space down here, right? It's irrelevant in this case. Later on, when you're playing with legends and stuff like that, there's a reason where you might want to move it somewhere else, but we won't get into that right now. But there are reasons. Outside of the aesthetics call, I can still change other things like size, but in this case, it's not an aesthetic. I'm just saying specifically, I want the size of the points to be full. There you go, right here. Open, open, close, close. Yeah. Sometimes you have to. Good point. Good question. By default, whenever you set an aesthetic to something that's a categorical factor, it's going to pick colors for you by default, and the default ones in ggplot are this red and this blue. And you will never see me use. I don't know why, but I can't stand the defaults in ggplot. But that's what it gives you by default. Some people really like them. It's not bad. They're not bad colors. No. And I'm going to give you an example now where I actually changed it because I like to do that thing. But yeah, the important things here is you can move this if you want up here. You can have it there. You can set the size. So I wanted to make bigger points. And then I used a different theme. Last time I used theme _ black and white. Now I just wanted to show you the variety, right? Now I use theme _ minimal. And we don't have the grid lines around the outside, right? It was enclosed in a box before. Let me just show you the beginner. You see how, well, you can't really tell here, but there's something around the outside. In the theme minimal, it takes that away. Okay? I just wanted to show you something different. Carlos. There is a way to control that, but specifically in that case, when I render that document, it uses whatever the width of the document is, and it makes all those more rectangles. You can actually set the aspect ratio to whatever you want. In fact, whenever I'm making plots, I almost always do it like a 9:16, like movie theater, like whatever you're watching on your TVs at home, rather than just specific squares, unless there's a reason to use squares. Yeah, but you can control that completely. Yeah. So this is what kind of worked best, since I needed to put the code on one side of this here to make it more of a square. Yep. Notice I added another call here to theme where I can control where the legend goes, right? By default, ggplot will put the legend outside of the plot on the side here, but that didn't work well for this presentation because I have limited space horizontally. So I moved it using this call right here. I moved it inside. I put it in the upper left-hand corner, right? Specifically, I go legend position is the argument of the theme function. And then I gave it C means concatenate. So C just means I'm going to put a couple of variables inside there. The first one is X, the second one is Y. So 0.15 on the X axis is, far to the left. And then 0.85 from the ground up is, almost one, so it's up there, upper left. You can control that. You can put it anywhere you want by playing with these numbers right here. So if you're doing the WebR version and you change that number and you rerun it, you'll see the plot move, the legend moves. Okay. Just out of curiosity, how many of you guys are using the WebR version and running? Is it working okay? Okay, cool. All right. So that's just an example of that. Let's look at the advanced option. Here's one where I chuck a spirit to it, right? I fit a line because I'm a barbarian. Let's go through it. Adjust colors, add a regression line. These are the things that I change. And as you can see, the code is getting longer, right? Once we start playing with things, it starts to get a little bit longer. First two lines are exactly the same. My ggplot call, I map the aesthetics to the data. My geom point here, I changed it. And before I had color equals group, I changed it to fill equals group. What does that do? It controls the inside color of the point, but then its outside has a different color, right? If you look at the one before that, it's just one solid color, right? On this one, it's two different colors, really. There's black around all of them, and then inside of it, it's like gold and blue or something. I don't know. Or blue or gold and gray, maybe? No? I'm bad at color. Again, I chose what size. PCH here represents what shape it is. So 21 specifically is a circle that's hollow and it's empty on the inside of it, right? So if I hadn't specified anything for fill, it would have just been white and print, but with the circle on the outside. Sometimes that's what you want, but I wanted to play with the fill just to show you. What else? Geom smooth. We talked about this before as one of the geometric objects. Now, there's different options here for the method. I chose LM, which stands for linear model, which means just fit a straight line to it, right? If you're using WebR, if you take this method equals LM and the comma and you just delete it, actually, the whole thing, if you take from method all the way to the end, just delete that. So it's just opening parentheses, closing parentheses. It'll give you like a curved line. It'll give you a smoother that's not a linear model, right? Linear models are always straight lines. Well, not always straight lines. Usually they're straight lines. The statistician's like, hey, wait a minute. We're not talking about GAMs yet or anything like that, right? But you can see what the two different things are. Most of the time, you'll probably want to do something like that. Now, here's the first time where you're seeing the color blindness aspect of it. Now, whenever you have an aesthetic, where's an aesthetic mapping? Right here, for example, fill equals group. You can play with the colors using a different function. So scale underscore fill means I'm going to control what goes in this fill. And then there's a package called Viridis. And this Viridis package is colorblind friendly. So if you use that and you select something from that, you know that it'll be colorblind friendly. So I use scale, fill, Viridis. Underscore D means discrete. So it's not for a continuous variable. It's for a discrete categorical factor type thing. And then you can play around with it. You notice in intermediate, the legend had a title, which I think was group, right? In this one, in the scale field Viridis, I said name equals null. I took away group because really, it's a group. That doesn't give us more information. I just need to know bilingual versus monolingual. I can say what option I want. So there's different color palettes inside of Viridis that are all colorblind friendly. I use E, but it goes from A to E. So if you guys go and you're playing in the code and you change option to A, uppercase A, and then run it again, you'll see different colors. Okay? The way that this palette works is it always has begin and end. By default, it begins at 0 and ends at 1, right? But you can change that. I changed the beginning to be 0.4 and the end to be 0.8. If you don't like this light yellow weird color, you can change it to like 0.7. It'll get darker, right? The lower the value, closer to 0, the darker. The higher, the closer to 1, the lighter. Okay? And that's all I did inside of that. So you notice in the advanced ones, I'm kind of tweaking all of the specific options and all the things you can do. If those overwhelm you, just ignore them for now and focus on beginning. What else did I do? I used the same theme as before. I didn't change anything here. And then the legend position, I left that the same as well. So all I really played with here was the colors and the smooth. Okay. I think this is my favorite type of plot, right? A scatter plot with a line through it. That's where I like the most information for my money. Yeah. Model. Yeah. Yeah. So usually when you do a linear model, it's like y as a function of something. And in this case, I just wanted normal y as a function of x. But you could do something like you can make it like a quadratic formula so that it's fitting a curved line. You could do weird stuff that in this case, it's not important. But I put this here specifically. You can take it out and by default, it'll do that. But I put it here because if I don't, then it'll give you a warning. And I didn't want you guys to get scared with the warning. I'm looking out for your game. Mm-hmm. I don't know because I'm not colorblind, but in theory it is. Yeah, in theory it is. I know. I don't know. Yeah. What did you make them closer together? Yeah, yeah, it's gonna make them. Yeah. I mean, that makes sense. We'll go back to the crap, the C and crap. We want to contrast them more if possible. I really dislike the extreme end, like the 0.9 closer to 1, because it's just too light for me. I can't see it very well. So I always go a little bit lower. Normally I wouldn't go to 0.4, but I wanted you guys to see the begin and my research. You got to pick that and test it out a little bit. But if you just leave the default and don't play with it, you can rest assured that that'll be probably the best option. Of the extra points, the inside of the points. Yeah. 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 Try changing option E to option A. And you'll clearly see it there. But then if you change the 0.8 to 1, for example, you should be able to see it pretty big. Yeah. Question? Nope. There are cases when it can't, like it does make a difference, but it'll still work. Right. So that's a really good question. Listen up. If I were to change the order, if I took this geom smooth and put it above geom point, it will still give me a plot. It's not going to fail. It'll still work. But what you see here on the line and like the shaded green for the confidence interval will be before the points. So the points will be on top of that. And sometimes that's preferable. If it's underneath it, then it means the color of this is going to be slightly different because there's a shade on top of it. So sometimes in fact, I usually put the points on top of it. Right? That's a really good point because it does matter the order, right? It's a lasagna, right? You want the meat and then another layer of what else do we put in lasagna? Cheese and then another whatever. Yeah, but that's the idea. Yeah. Yep. Yep. Well, that's what the default is that I chose here. By default, if you just run this without putting anything in, it'll be 0, 1. Yeah, and then it'll automatically pick. So imagine in this case, it'll try to do the most contrasting thing by default. Crap, right? If I have more levels in this factor, if I had bilingual, monolingual, trilingual, blah, 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 then it'll divide the space up into however many levels there are. So if I only have 2, then I use 0 and 1. If I have 5, it'll be 0, 1, 0.2, 0.4, 0.6, 0.8. So I had to do some quick math there. Exactly. Dispersion theory, right? Do we use up all the vowel space? By default, this will use up all the vowel space. Okay, I like that. All right. Should I move on? All right, let's look at some more. How am I doing on time? Am I okay? Yeah. Yeah, good point. Okay, so let's talk about the box plot, or the box and whisker plot is the official name. Same as before, by default, I'm starting off with my template. We've got the mapping. In this case, what I map to the x-axis here is a categorical factor. It is not a continuous variable, and that is the basis for why I wanted a different type of plot here. So I use geom underscore box plot, and it spits out this by default, right? If I don't change anything else, this is my box plot. Okay. Nothing too difficult here. If we go to intermediate, okay, let's play with the colors and let's change the theme. I use a theme we hadn't seen yet before, right? Now we have on the left side and underneath, we have lines, but then it's open on the top and on the right. This is a classic one. Is that what it's called? Theme classic. It's a classic one, right? What's new? I did the same thing I did before. I have all the aesthetics on one line. So what I did in the one previous, I put like the fill or the color inside the geom. In this case, I left it in aesthetics, but I could take this and I could move it inside there if I wanted. It would still work the same. This is just more compact, right? So geom box plot without changing anything, but since I have a fill aesthetic, again, I can use scale underscore fill viridis discrete, and then I change the begin and the end. And in this case, it's option A. No, it's option, I think it's option D or option E by default. I don't remember which option. It's not one of like the ones that looks like a volcano or fire and stuff. It gives me these pretty green and blue ones. Okay, I like these, right? And then I changed the base size, but I didn't change the font. You can see it's the ugly font again. And then I moved the legend to the upper right rather than the upper left, right? Sometimes you have to say like, where is my data in the plot? And then you decide where to put your legend to kind of keep it out of the way. If you have a lot of space, you can put it outside the plot. Yes. Yeah, that would be the theme. That would be the theme. Yeah, so like if you leave the default, the background will be gray. If you do like theme minimal, it'll be white but with gray grid lines. Theme classic just doesn't happens to be white and it has no grid lines. Yeah, I like the grid lines. I don't like the default. They're really thick and like the weird gray. I always change that stuff. Usually I do something like this with no grid lines. If it's a scatter plot, they can be helpful. For this, I think it's okay. Yeah, this intermediate one was actually pretty easy. Any questions here? If you want, again, you can play with the numbers here and you'll see how these change. Another thing that no, actually, I'll probably do that next one. I don't want to get too far ahead. Yep. 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 The extremes. It's like limiting the extremes. So let's go advanced. Now, this is what I was talking about before, where I prefer to see raw data. Right? So that's what we did here. I overlay the raw data. And in this case, really, I played around with this. I moved the aesthetic call for the fill to the box plot just to show you that you can. Again, it doesn't change anything. I said show legend equals false, and you'll see there's no legend anymore. For example, if it's just two groups and it says it right here on the x-axis, why do I need a legend? So sometimes you want to get rid of that. Easy to do. Show legend equals false. Now, instead of geom underscore point, which you guys saw before, I chose a different one, a different option, which is geom underscore jitter. What that does is it jitters the points, it moves them around horizontally, not vertically, because that would affect our score a bit. So the way you see that is height, right? Vertically, 0, which means don't change the height, because obviously that's important here, it's the actual score. But vertically, it doesn't mean anything, right? So width, 0.2, and you can see how wide this gets. If you change this to like 0.6, you'll see the points spread out really far, right? What else did I do? I made the size. Alpha is how opaque they are. Right? Because I don't want it to be the whole story, but I want you to see that there's points there, right? So if you want, you can change alpha equals 0.9 and they'll get really dark or darker. The extreme is 1, right? But usually some opacity there can be quite useful. So then it's not really distracting from the box plot, but if I want, I can see all the data. Now, if you choose box plots, those are what you want to do. I would strongly recommend that you plot the raw data as well, right? Because then you can just see everything. There's nothing left to the imagination. Yeah. Data or naked, I don't know, whatever. What else did I do? Labs x equals yes. By default, also, it gives you a label for the x-axis, which in this case was group. I set x equals null. I got rid of that because what's the point? If I can just see what the label is, I know what I got there. If I look back at intermediate, you'll see that right here it says group. Right? I just think that in that case it's kind of pointless. So in advanced, I just got rid of that. Yep. So whenever you do geom underscore jitter, what it does is it takes whatever points you have and it just moves them around in a certain direction. In this case, I don't want to jitter vertically because the vertical axis represents a score. So that would be misleading. I would be changing what the actual scores were. So I set height to 0, but I do want to jitter the width because I didn't want them all to just be in a straight line. In fact, how would do this? In WebR, change width to 0 and then run it again. Yeah, no, don't change height. Don't change height in this one. Yeah. Change the width, put it at 0, and then put it to like 5 or 0.5 or something. You'll see that they get wider out. It just makes it easier because imagine that if you have a lot of scores that are the exact same value, they'll be plotted right on top of each other. Yeah, but sometimes it's annoying, right? Because you want to see like how many are there, right? So it's kind of like, it's all it is. That's all it is. In fact, if you want to, you could change it to geom point rather than geom jitter. It'll do the same thing. It'll just plot them all on the same line, the same vertical plane. Okay. Any questions about the box plot? Okay, this was the part where I think I talked about the interquartile range. We already saw this, so I'll keep going. In my personal opinion, I think there's a better way. I'm not a big fan of the box plot. I prefer a point estimate with spread, with some type of measure of spread, because then you can quantify uncertainty and everyone can see that. So we'll do the same thing, beginner, intermediate, advanced. We'll work through how this can get better, right? But this should be the start. We use our template. We have our data frame. We map the data. Again, this is all the same. Instead of geom box plot, I'm using the stat summary that I talked about before. So this has a couple important arguments. I'm going to say fun.data. I want to get the mean and the standard deviation. I already mentioned this. And then the geom I want is the point range. So this is what we see. A point estimate of the mean, and then a line representing the standard deviation. Okay? I like these. These are cool. I use these all the time. We can do better, right? We can do better. We'll go to intermediate, and I put the points on there. Now, this is a case where this works perfect with our previous example, Alicia, because now I have geom point, but I didn't jitter it, so you can see they're all on the same vertical plane, right? That's okay, but if you have points on top of each other, or if they're behind this or on top of this, you can't see them, right? So you can't see all the data. And I'm not sure, but I'm guessing if in the advanced, I probably jittered them. Yeah, there you go, right? So I'll just stick to this one. And you can also see here, this is getting a lot longer, right? That's because I played around with the theme a little bit more and did some other silly stuff, just to show you possibilities. In fact, what I was thinking when I prepared this was that you could use these as like templates and say, oh, I have something where I need to use a measure of spread, and you can look at this, copy and paste it, and then change it to modify it so it works with your code, right? So some of the things that I changed here, let's look at this. I did the jitter. Again, I moved the aesthetic for group inside of the stat summary just to show you that you can put this anywhere you want, right? So this is how we're going to deal with the fill inside of the colors here. Fun data, instead of the mean and the standard deviation, I did the mean and the standard error. There's a lot of different choices. That's something different. I'm still using the point range. So you see a point and then a range representing the standard error. PCH, I'm changing the type of point. So this is one that's hollow. So that means the outline is black and then the inside is whatever color I chose. I got rid of the legend again, blah, blah, blah. I specifically said, okay, what do we want the Y to be? I think before it was like a percent or something, like score with an uppercase S. I don't want anything on the X-axis. And then I said, let's add a caption, right? You can do basically anything you want. So you see down here, there's a caption, mean plus or minus standard error, right? Which is what we get from my here standard error. You have to copy and paste that weird character there. Plus minus time. Again, we use the scale fill gridis, right, for our group aspect right here. I chose a different option. I chose A. 0.2 for when I look at it here, it looks black, but I'm pretty sure on your screens it's probably purple, right? Yeah. You can change A to B, C, D, whatever. You can change where it begins, where it ends, and the colors will all adjust accordingly. What else is worth mentioning here? I played around with the theme. Okay, so this down here at the bottom, honestly, none of these things are important, but this is just me playing Carlos. I told you before, I don't like the grid lines by default. So what I did here, I made them slightly lighter and thinner. And then I moved where the axis title is. And normally it's like right here in the middle. I moved it up to the top, and then I moved it further to the right, but you can't see it. So this is just customization, just to show you the possibility, right? Clearly, this is subjective. None of this is required, just so you guys see kind of the power of what it can do. That's why it's in the advanced tab, okay? Yep, I think it's horizontal adjustment. Yeah, probably. Yeah, maybe that's probably height adjustment. Then I don't know. I think it's weird because since it's one that's plotted sideways, I think it's still horizontal, but as if you were looking. Because there's H just and V just, and V is vertical. So if I change the vertical, but it just happens to be on Y, it would have moved it this way. Yeah, that's quirky, right? But, yeah, but if you're doing it on the horizontal axis, then it makes sense. I think it's because when they initially added that argument, it was for things like on the plot. So H just makes sense because it goes this way. Anyway, how do we feel about that one? Nah, no excuse. No. See. Okay. It's from the jitter. So by default, the jitter right here, the algorithm that it uses to adjust it horizontally, it's different every time. There's no way you can like set the seed so that it puts them exactly the same place, but it doesn't matter. So like this point right here, the horizontally is always going to be at the same part of score, but vertically it might be a little bit over here, a little bit over here. That doesn't matter. So if you run it and then you run again, then you run again, then you run again, the points are always going to shift horizontally. Yeah. It's I don't really remember. So that's a good question. I don't know the answer. So like, what would I do if I wanted to figure that out? I'll show you real quick. So I'm going to go, I actually just happen to have RStudio open right here. So I'll go question mark geom jitter to get the help file. And when I look at the help file, I'm pretty sure there's a hide show inherit. There might not be a way to set the seed position with height show that inherit. No. You might, okay, so you might have to set the seed outside of that. Let me just make something up real quick and see if it works. Yeah, but yeah, the jitter doesn't matter for that. For other things, setting the seed can be really important. So we'll do VS Y equals pretty sure I don't have anything open. Hang on. Tidy verse. Tidy without it. Tidy. Okay, let me just send this real quick. Okay. Now VS isn't the one I want. Hang on a second. Let me find something categorical. 01. Oh yeah, VS, but I have to set it as a factor. You guys making me improvise on the spot. The live coding, I forget how to type. Okay, there we go. So the jitter is that width. I don't know, pick a point, any point here, and then see, you'll see how it changes. I'll run it again. We already confirmed this. Okay, they're moving horizontally, right? Is that the case? Just to make sure, I'll say height equals 0. So they're just moving around horizontally. Now what I'm going to do, we'll see if this works. Set, seed, I'll just say 1. You could pick any number here, it doesn't matter. Run it again. Okay, there it is. Let's see if it does the same thing again. There we go. See that? Now it's not moving. Right? So if you set the seed, then the jitter will be the same. That could be important for something else. For this specifically, it's irrelevant. Right? Okay. But very good question, because you look at it, seeing it differently, like, am I getting different with something? It doesn't affect like where the stat summary is or anything like that. Are we good? Okay. What else do I have? Faceting. So sometimes you need to see more than one factor at once. You want to see kind of like multiple plots side by side. It's actually really easy to do. In the example that we have here, I said, what if we want to see score as a function of proficiency, and age at the same time? There's 2 functions that we can use for faceting. There's facet underscore wrap and facet underscore grid. I don't know why, but I always use facet underscore grid. It's pretty simple to use. It's just one that I go to by default. So this is what it would look like in our call here, right? So we have proficiency score, and then I go, I don't know why the syntax is like this, but it's point, tilde, and then age. And that'll make it faceted horizontally. If I flip these around and I go age, tilde, point, then it'll facet vertically, right? And then I just do the rest the same. I'm pretty sure that's what I showed here, right? No, point right here is something like under the hood that R does, where it's like as a function of everything else, but it doesn't represent anything else. So it's just like you're always going to use it. Age will change based on what you have in your data frame. The point will always be the same. So point in the age, it gives me all of the factors of age faceted vertically, right? So we see the younger have higher scores, the older less, lower scores, and the oldest lowest scores, right? I don't know if I put the other one. It wouldn't make sense. So I'll say, yeah. So you could also facet vertically. And this in case I changed it to group because I didn't have enough room to do all 3. So for the group factor, we had bilingual, monolingual, so we can look at them like this. This can be really useful if you want to compare the young, right, from both groups who's looking vertically. Maybe not in this case, actually, because you can't really see where it's at here, but whatever. You can facet in both directions. And if you put, for example, if I were to put group here and instead of the period, I put age, then it would do both at the same time, vertically and horizontally, which can be useful. If you're using WebR and you have this example, you can actually put them both there if you want to and break things around. You'll probably have some subsets where there's not enough data to put a box plot there. It should work. Ah, and the bilinguals on the bottom. Yeah. So by default, what R does is it's alphabetical. So young, older, oldest. Maybe it's reverse alphabetical here. Older. Yeah, then I don't know. I might have said it that way. Oh no. I probably said it this way on purpose under the hood so that it made sense chronologically. Yeah. In this case, it did it. So the way that you would do that, I'll show you what the code looks like, but I'm probably not going to run it right now because, oh, maybe I will. Whatever. Whoa, where'd I go? Showing you guys my email. Oops. So this part right here where I set this as a factor. So like by default, this has zeros and ones. So you see right there, 0 factor 1. It just, it's going in order. If I wanted to change that, this is kind of annoying. Okay, so I do something like mutate VS equals fact reorder. No, we'll do relevel. Relevel VS is the one I'm working with, and I want to put actually, hold on. This is going to take 2 steps. Sorry. I'm going to have to do this one doesn't have names yet. I'm sorry. As factor VS. Let me just check this real quick. So that means now I don't need this here because it's already a factor. This should just do the same thing. There we go. And now what I will do is add to this VS equals factor level. So right now we have 0 first and then 1. So I'm going to go VS. And what I want to do is put first 1 rather than the other one. So now it's switched the order, 1 and then 0. Right. So the important thing is I use this call mutate to mutate the columns, and then I just adjusted them. First, I set VS, which was a categorical vector in the data frame. I set it as a factor. Remember before when you said, why does that one have it just says character, and then the other one gives you, I changed it so that they're the same. And then in the next one, I re-leveled it. Right. So I said, give me in this VS factor, give me the 1 first instead of the 0. Exactly. Right. At the end of the day, it makes sense. That's kind of like a problem whenever you have a column in your data frame where you use numbers for something where you could say like group 2 instead of just 2 or something like that. But no. R does some quirky stuff under the hood. That makes sense? That was an aside, but probably worth mentioning. Okay. So we have time. Do we have time? 2:54. Are we okay? In theory, we have like 45 minutes, but I don't know if we'll go 45 minutes. There you go. Let's take a step back. You can use, if you're using WebR, you can use like one of the consoles to do this and kind of play around with this. And these are kind of like, they're not like challenges, but some things you can do, right? So I say using the new data frame, create the following. You can just go through and do some of these that you might be interested in. If you have problems, just like I'll come around and we can help each other or whatever. Or if you're tired, you don't want to do that anymore, I don't know, we can stop. This is kind of like whatever. Let me see if there's anything else I wanted to say. Okay, let me say one more thing and then we'll go to the exercises. So this is an ideal way of doing things where we're like just plotting data, but most of the times we're fitting models, right? And we're using these models for our statistical inferences. That's how we're deciding if something is significant or whatever it is. That's where does it get published or not, all those horrible things. I think that since the models are what we're using to make these decisions, a lot of times it makes sense to plot the model as well as the raw data, right? And that's something I stress to anyone that'll listen to me yap about it. And here's an example where I do that. The details of this are not important, just kind of watching what I do and I'll explain what it does. So I'm fitting a model here using the same data. It's a Bayesian model. If you guys know about that kind of stuff, I know you do. The line 4 and 5 at the top is fitting a statistical model. And then what I'm doing in the rest of this is I'm using that model to make predictions, and then I plot the data on top of that. One day you might come back to this and you'll be like, oh, cool, what did he actually do here? Right now, just kind of take my word for what I did and I'll show you what it looks like, right? And these can be really cool. So the idea is I have these points scored proficiency. We've been looking at that for the past hour and a half or whatever. I fit that model that I showed you in lines 4 and 5. And I said, okay, given the data that we have and my prior assumptions about this data, fit this model to it and give me predictions about what all of the possible lines could be fitting through with them. And then out of all of those possibilities, give me the ones that are the most plausible. I'm going to plot them on here. And then I'll average that together to give me like one good estimate of what that line looks like. And that's what in a statistical model where I'm writing up my results, that would be what I use. Like this is significant, that's not significant, whatever, right? So that's what you see in red. That's like the average plausible line of best fit, I guess you could say. And what you see in white are other other models that are consistent with the data. You know, there are other possibilities. They're just not like the most likely. So this is a way for me to plot my model and then uncertainty around that estimate, right? Like for me, this is like the standard. This is not necessarily the colors, right? I just put it in black, like black, whatever, the presentation. But this is like what I want to see whenever I read the model, right? I can see the model, I can see the raw data, and I can see uncertainty around the model, right? So I think that kind of the takeaway message here is like, this is what we should strive for as you move along, right? We start off with these kind of toy ones to understand the framework, but if you're using statistics to make decisions, then you want to plot the model as well, okay? And I'll get off my high horse here. I'm always like yelling about this stuff whenever I read the articles and stuff like that. So what did we learn? Whoa, did it again. It's embedded in my brain. Remember crap. Colorblind friendly palettes are important. In all of the examples we've seen here, I used the Veritas color palette. You can actually like Google that. There's information about it, how they designed it, if you have questions about the color blindness aspect of it. Highlight things that are important. Highlight things that you want people to know, that you want people to understand. You want people to see. Hold on, let me look at one thing. Sorry, I just read that and then I said I didn't point it out when I went to the plot. So I say score is a function. You probably read this and I didn't, right? 300 draws from the posterior. This wasn't important. I thought I said something else. So never mind, ignore me. I thought I said something like most plausible line of best fit or something, but I didn't. I would if it was an article. Help your target audience. Help your reader understand what you want them to understand. When you're presenting, do this as well. Take them, hold their hands, even though it costs you an extra 30 seconds of your presenter time. Say, right here, this is that. What I want you to understand from this is this, right? That's how you take people with you. Plot raw data and a statistical summary or model of the estimates whenever possible. At a minimum, raw data and a statistical summary, right? But what you want to strive for, what you want to work toward is having your models in the plots as well. And I've given you less examples of that, but you do have the code for the example I did there. I talked about that last. Some bad principles. I say according to the internet, because I always see like on Twitter and people have opinions about plots, right? And these are just some of the things that you might see a lot. I'm not necessarily saying that these are good or bad, but I'm just saying like there's kind of like a general consensus out there that people have strong feelings about these things, right? Plots without context obviously are bad. Illegible fonts. Usually with fonts, you don't want to get cute. You just want things to like represent, like if it's a title, subtitle, and be consistent. But crazy fonts, people seem to hate Comic Sans, for example. I don't know, maybe you want to avoid that. I'll leave that up to you. A line graph with an unordered x-axis is obviously a bad thing. You don't want a legend that has a bunch of different categories and stuff. I mean, if there's no way around it, maybe there's no way around it, but usually these are things you want to think about. Personally, I would say avoid pie charts. Maybe scientific notation is something to avoid on axes. I don't really care about that, but someone had a list of these things and some of these were on there. Uninterpretable variable names. This is a big one. Like group 1, group 2, like usually that's something you want to avoid. People really hate on dual y-axes where you see like a y-axis on the left side and then one on the right side and they represent different things. People seem to really hate those. I mean, I don't really have a big problem with it. I guess if there's a context in which it could make sense, but in general, that's what people say. Bar plots could almost always be box plots unless it's counts. So I would say it's probably best to avoid those unless it's counts. That's one where I personally have feelings about it. Non-colorblind friendly color scales are a bad thing. And then people seem to hate angled text. I don't know, sometimes it's really useful, but I've read people like harp on that before, so things to keep in mind. I want to give some examples of really bad plots, and maybe we can think of our crap and see like why they're bad. Let's troubleshoot these plots. This is chaos, right? Oh my God. You will see this a lot where people do these comparisons to show you like pairwise comparisons if something is significant or not. Personally, I mean, first of all, doing this many pairwise comparisons is a huge problem in and of itself. We can talk about that later, but I don't ever do this. I don't put these kinds of things on there. Like if I'm doing a presentation, I'm going to tell you. I'm going to be like, if I compare this to this, this is the whatever. Like usually tell the person what you want them to know. If they have a question about a specific comparison, let them ask you, right? If it's a paper, you have a caption and you have your text to tell people what to look at and what things you're comparing. I personally would avoid that. If you prefer that or someone asks you to do it and you have to or whatever, like that's a different story. But yeah, what else is wrong with this? Yes. Yeah, what is this? 6,000 what? What is going? Yeah, bar plots. Yeah, there's a lot going on here. This isn't mine. I don't know who made this. So hopefully, no. Yeah, I say hopefully I never meet this person someday and they get mad at me. But Okay. This one was mine. I already admitted to that. What's wrong with this one? Can't see it. Completely. I didn't know. Yeah. The y-axis was a score for like the source credibility rating. So like the higher, the more credible they were. Right. It was like a match guide test. I used this plot in Ana Carvalho's class for the presentation. It's so embarrassing now. You know, has everyone ever had class with her before? You're gonna watch this video. Hi, Anna. We would always talk about like our students in class, but she would be sitting in the back and she would just make faces, and you could tell if she didn't like what you're doing, and doing something like that. Now, I got one of those faces with this for sure. You can't tell what I'm trying to show you. The colors are horrible. There's just a lot going on here that's pretty horrible. Right? I think we can agree. What about this? Those are beautiful flowers, right? I don't. But what is the year by date? Like what is I don't know. This one's wild. I saw this on Twitter. This was an actual plot. I was like saving that one. That's awesome. I honestly don't know what this is about. Is that a volcano or something? The river. It looks like art. It doesn't really look like yeah, it's art. Even the font is yeah, it's a little extra. Yeah. It's something over time. I don't know. This might have been like a joke or something. Honestly, I don't know, but yeah. It's chaos. It's chaos. What about, is there another one? No, that was it. Why is it connected? Right? If you connect things, there needs to be a really clear reason for that. It should be obvious. Yeah, I don't know. I don't know. All right. So some concluding ideas, and if there's interest, we can go back to exercises, whatnot. Um, Resources. My good friend Timo, I talked about him in the other presentation. He has a website and a YouTube channel, and he's obsessive about data visualization stuff. He's much more extreme about this kind of stuff than I am. He has strong opinions about some things as well. His YouTube channel is great. He's very good at hand holding and walking you through these types of things. So I would recommend taking a look at that if you're interested. There are complete classes on data visualization. A lot of the information that I got here come from this data visualization R course. It's all open source, and you can peruse that if you will. I want to teach a data visualization class, and that'd be really fun. There's also books on the subject, all kinds of really cool stuff here. These two here are different books. Actually, all three of these are books. So if you do like this and you want to play around with this and learn more, it's a really horrible hobby to have because you become obsessive and it takes up a lot of time, but it's a lot of fun. I think these are good places to get started. And again, thank you very much for your attention. I have a lot of fun doing this. Again, we can keep going and play with examples and stuff, but I'll like officially stop. We like stop recording here and stuff. All the materials are there. And if you ever have questions or you have problems with your code and stuff like that, feel free to email me. I'm happy to help out with that kind of stuff. I do like it. All right. We'll call that